Today's lesson is about direct variation. We're continuing that today, but today instead of a table, we are going to be looking at what the equation looks like when you have direct variation. So let's look at this first example. You have Jerome and he's driving at a constant speed of 50 miles an hour. You're going to complete the table to show the distance that he travels. Well, there's a key phrase here that you can tell that this is going to have direct variation because he is traveling at a constant speed. So because it's constant, they basically gave you the k amount, which means I'm going to be multiplying each of my x values by 50 to find my y values. So I'm just going to come down here and do times 50. So we're going to fill out this table. So the first answer is 50, 100, 150, and 200. So the first question says, how did you calculate the distance? Well, I multiplied miles by 50 because that k value is 50. So because my k value is 50 and I know the equation that I'm looking for is y equals kx, I'm just going to put that 50 in here, and there's my equation. Well, here is, do each of these set of values or in the table form proportions? Well, let's just look real quick. I have 1 over 50 because it's going to be y over x like this says. Oh, did that backwards, didn't I? Let's do this. So I have 50 over 1, and then I have 100 over 2, and then I have 150 over 3, and I have, whoops, I missed that 0. I have 200 over 4. Well, those are all equal to each other. So it does have proportionality. So the constant of variation, or that k value, is my 50. Okay, so let's look at another one here. So Gupta is making cookies, and for each dozen, it takes 1 cup of sugar. So if I'm looking at that, each dozen takes a cup of sugar. So here I have 1 cup of sugar, and it gives me 12 cookies. So it kind of says each dozen takes 1 cup. So that's kind of that constant of variation. So I know that this is going to be my constant. So a dozen, remember, is 12. So I'm just going to take each of these and multiply by 12 to fill out my table. So I'm going to have 24, 36, 48. So how did I calculate the number of cookies? I took cups of sugar and multiplied by 12. So when I write the equation, my k value is that 12. Does it show direct variation? Well, let's just fill this out, y over x. So I have 12 over 2, 1. 24 over 2, 36 over 3, and 48 over 4. So those all work out. So it does have direct variation, and my constant is that 12. So let's look at something else here. So we have Snappy Bike Rentals, and they charge $2 per hour. Remember, per means multiplication. So for every hour, I'm going to be multiplying times 2. But then they charge you $3 for insurance when you rent the bike. That's not per hour. That's just a flat $3. So up here, I've got times 2 for all of my hours, right? But then I have this plus 3. So I'm going to add that 3 every time. So let's see what we have. If I rent my bike for 1 hour, and then I add the $3, it's going to cost me $5. If I rent it for 2 hours, that's 4 plus 3, 7. If I rent it for 3 hours, so 6 plus 3, 9. And if I rent it for 4 hours, that's at 8 plus 3 is 11. So how did I calculate? I did $2 per hour, and then I added 3. So when I write the equation, what I really did is I took my y value is going to be equal to 2 times my number of hours plus 3. Well, let's see if this has direct variation in this y over x thing. So I have 5 over 1, 7 over 2, 9 over 3, and 11 over 4. Well, if you want to do this cross multiplication thing, you can do times and times, right? So this is 7 and this is 10. Well, right away, I know they don't have direct variation. So my answer is a no. So because it doesn't have direct variation, there is no constant of variation. So I'm just going to say none, because there's nothing I can multiply by 1 to get 5, and then do that same thing times 2 to get 7, or by 3 to get 9. So there's no number that I can use consistently or constantly throughout the table as a pure multiplication problem. So let's move on here to this one, see what this looks like. So I have Stephanie, and she's putting gas in her car, and it costs $3 a gallon. There's that per. And then she buys a $2 candy bar. So when I look at this, what I'm really going to be doing is I'm going to taking her gallons times 3, but then I'm adding that $2. So no matter how many gallons she buys, it's $3 a gallon, and then she adds that candy bar. So let's look at here what's going to happen. So she buys 4 gallons at $3 a gallon, but then she adds that candy bar. That's where that 14 comes from. Then she buys 6 gallons. So this is going to be a 20. And she buys 8 gallons. This is going to be 26. And then she buys 10 gallons. That's going to be 32. So how did I calculate the cost? I did $3 for each gallon. And then I added $2. And I said plus 3 down here, and that's just not true. So do I have to recalculate these? So 18 and 2, 24 and 2, 30 and 2. I don't. You know me, I always do something like that. So here we have my y value is going to be equal to $3 per gallon plus the $2 for the candy bar. So let's look. If I have 14 over 4, I have 20 over 6, I have 26 over 8, and then I have 32 over 10. So if I want to do that cross multiplication just to see what's happening, this is 80, this is 84. They do not have direct variation. Since they do not, there is no constant of variation, because nothing times 4 gives me 14, and then I can use that same number for each one of them. So that does not have constant of variation. So I'm just going to fill these out here, what does and does not, so we can just take a look at what happens. So this is y equals 3x plus 2. That's the first one. That does not have direct variation. And the other one was 2x plus 3. So y equals 2x plus 3. This first one was y equals 50x, if I remember correctly. And then the next one was 12x. Well, you'll notice that the ones that don't have direct variation have this addition problem on the end of it. And that kind of changes that direct variation, because you're not just multiplying, but you're also adding. So it takes away your direct variation. So when you're looking, let me just say one more thing. When you're looking for a direct variation equation, it is going to look like that y equals kx. Okay, so let's look at these. Find the constant of variation and then write the equation for the following direct variations. So they are telling you that they have direct variations, so that's a helpful thing to know. You do need to know that. So let's do some t-charts just so we can fill them out. So I'm going to just do a t-chart for each one. And how they're written really matters. So let's look at this. Y varies directly as x. So I know this means direct variation. So my y is 12. Like here's my first one. Y is 12. and x is 3. So now it wants to know what is y when x is 6. So I'm looking for my y. Because I know they have direct variation, I can just look at what my k value would be. My k value is 4 because I multiplied 4, which means my equation is y equals 4x. So when I multiply 6 by 4, I get 24. Okay, so let's look at this one. I have n is varying directly with p, which means that my n is my y value, because remember, y varies directly with x, and they're not always going to be x and y, so you've got to look at that. And that means my p value goes here. So then I know my n is 2, and my p is 4. And now it wants to know what is n. I'm looking for an n when p is 10. I know they are constant, so I'm looking for that k value. It looks like I divided by 2, and remember, this has to be a multiplication problem. So when you divide by 2, you actually multiply by 1/2. So my equation equals y equals 1/2. And actually, it's not a y anymore, is it? It's an n. It's 1/2 p. Well, that means this has to be a 5. You're just kind of filling in what you know for sure. So let's look at this one. V is varying directly with z, which means this is my v, and this is my z. So now it says v is 9, and z is 3, and I'm looking for what is z when v is 15. Well, my k value looks like it's a 3. So it's not y anymore. It's going to be v is equal to 3 times z. So that means this is a 5. So when you know what varies directly, when you know which variable varies directly with the other, you can pretty much change this to be your y and your x, and your y and your x. Like I said, they're not always going to be x and y, so you've got to be conscious of that, which is varying directly with the other, because that does identify your x and y.